Hello everyone. Today we are going to discuss about another topic in fluid mechanics, that is dimensional and model analysis. So we are going to see what is meant by secondary or derived quantities, Buckingham's pi theorem, and some more laws that relate the prototype and model. So first, to start with, dimensional analysis is actually a method of dimension. With this mathematical technique, we can conduct model tests. That is, it will deal with dimensions of the physical quantities. When I say physical quantities, we know the three fixed dimensions, that is length, mass, and time, right? These are the fundamental quantities. And using these fundamental quantities, we have something called as secondary or derived. Secondary or derived. So these quantities are those which possess more than one fundamental dimension. For example, velocity you can take. Velocity is actually distance by time, right? So distance will have the unit L and time will have the dimension quantity T. Therefore, it is LT minus 1, right? Similarly, we have density. Density is mass per unit volume. So when I say mass, the fundamental quantity is M, and for volume it is L cube. Therefore, it is ML minus 3. So the quantities which are dependent on the fundamental quantities and which have more than one fundamental dimension, then you call it as secondary or derived quantities, right? With this basic understanding, we'll check the dimensional homogeneity. So there is one term called as dimensional homogeneity. Let me take the velocity equation. V equals root 2 GH, right? I'm going to check the dimension value on the left hand side as well as on the right hand side. We know that for velocity it is LT minus 1. Let me check this side. So it is G is meter per second square, right? So it is L divided by T square into height, that is in terms of length only, and you take the root, you get the value as L by T, which is again LT minus 1. So on the LHS as well as the RHS, we have arrived at the same value. Therefore, I can say that dimensional homogeneity exists in this equation. So it can be used in any system of units. Okay, this verification we can do in any system of units. In continuation with that, we have two methods of dimensional analysis. Methods of dimensional analysis. The first one, you call it as Rayleigh method. And the next you have Buckingham's pi theorem. Okay. Now I'll tell you the basic difference between these two methods. Both are used for dimensional analysis only, but Rayleigh's method is preferable whenever the maximum number of variables are 3 or 4. That's all. It should not exceed 4. Okay. In cases where the number of variables are going to exceed 4, then you find this method to be quite difficult. Whereas Buckingham's pi theorem is comfortable even when the variables are exceeding 4. Okay, it is not so difficult to find the expression of the dependent variable. Now I have used two terms. One is the dependent variable, and other one is independent variable, right? So let me tell you what is that. I'll take the simple example. Velocity is distance by time. Now, velocity depends upon distance as well as time. So, in this case, these are called as independent variables, and this is called as dependent variable. Okay. Now, I'll take one simple question. I just state the problem, efficiency of a fan. So, there is one term, efficiency. Let me take it as eta. So, it is a function of, it is going to depend on density, that is rho first, and then dynamic viscosity of the fluid, therefore it is mu, and angular velocity, so I'll take it as omega, diameter of the rotor, that is d, and the discharge, so that is q. So the efficiency of a fan depends on 5 parameters, right? Express this efficiency in terms of dimensionless parameters. So they're asking you to derive an expression between all these and make sure that this efficiency depends on all these parameters, right? So as a first step, what we have to do is, first you have to see how many number of variables are involved. This is the first one, second, third, fourth, fifth, 5 variables, and here you have 6. So totally there are 6 variables. Let me write it as n. So n is equal to 6. Now we should write the dimension for all these variables independently. So density, that is going to be mass per unit volume. This you can write by yourself. Okay. Then for viscosity, dynamic viscosity, it is m L minus 1 T minus 1. For angular velocity, it is radians per second, right? So it is just T minus 1. For diameter, it is simply L. For Q, it is mass flow rate, right? So it is L cube per second. So it is T minus 1. Okay. And of course, for efficiency, you do not have any unit. So you have nothing to write for that. Now, you look at all these 5 terms. You notice that the fundamental quantities, that is M, L, and T, are present, right? So therefore, your M value is going to be the number of fundamental quantities present. Here, all 3 are present. So we'll take M as 3. Now, the next step is to find out the number of pi terms. This is Buckingham plus pi term. So n minus m, that will be your pi term. And in this case, your n is 6 and your m is 3. So 6 minus 3, it's going to be 3. Right? So your equation will be of the form function pi 1, comma pi 2, comma pi 3 will be equal to 0. So this is how your final expression is going to look. Right? Now, phi 1, we have to define all these, that is pi 1, pi 2 and pi 3. We have to define. So we'll be taking this in such a way, there should be, each pi term should have only m plus 1 number of variables. Okay. When I say m plus 1, already your m is 3. So it is 3 plus 1, 4 number of variables should be present here. Right? How many variables we have altogether? We have rho. I'll write it once again. We have mu. We have omega, diameter, q, and eta. So we have 6 variables, out of which we have to select only 4. Right? In this, this is the dependent variable. So the dependent variable can never become the repeated variables, right? There should be 3 repeated variables, and the other one can be the non-repeated variable. We have to identify the repeated variable. So what is the thumb rule for identifying the repeating variable is, the repeating variable should actually be chosen in such a way that it should denote the geometrical property of the system. The second one, flow property of the system. And next, the fluid property. So you should choose the variable in such a way that all these three are covered. So when I say geometrical property, I can select D, right? Flow property, I can see velocity if it is there. Here they have given angular velocity, so I can take omega. And fluid property, it can be density or viscosity. Density is a simpler one, I'm taking density. So I have chosen three repeating variables, and the other one will be the dependent variable. Okay, so only these three can be repeated. The first one is representing geometrical, the second one is flow property, and the third one is fluid property, right? The fourth variable can be your efficiency, right? Now we are going to choose the second pi equation. So this again will have d omega rho, and we are left out with the other one. So I'll take mu here. And what about pi 3? Again d omega rho. And the next one will be q, right? So this is the last one. So we have only two pi equations because the number of pi terms is supposed to be 3 in our case. Okay. Now this will be raised to the power a1. This is b1, c1. This is a2 power b2, c2, a3, b3, c3. Right? Now we have to write express these variables in terms of dimensions quantities. Okay. So I'll take the first equation, I1. That is going to be for for the diameter, you have the length only, right? As the dimension. So this is to the power a1. And then you have t to the power minus 1 because it is angular velocity, right? So t to the power minus 1 to the power b1. And then you have for density, it is ml minus 3 to the power c1. And of course, for efficiency, you do not have any unit. Okay. So this is again equal to m naught L naught T naught. This is your pi 1. Now I'll simply equate the values of m and L on both sides of the equation. So 0 will be equal to C1. And for L, it is going to be A1 minus 3 C1. This is for L. And this is for T. It's going to be 0 equals B1. Right? So solving these three, we will get the values as C1 is equal to 0, A1 is 0, and B1 is also 0. So substituting the values of A1, B1 and C1, what you will get? You'll only get d to the power 0, omega to the power 0, rho to the power 0, and eta. Therefore, your pi 1 is nothing but eta itself. Okay. Now I'm going to repeat this for pi 2 and pi 3. You can also do simultaneously with me. If you're struck up anywhere, you can just cross check what is on the board. This was your second equation. And of course, the non-repeating variable in this case is mu, right? So again, I'll write the, the dimensional quantities. Right? So this side again, it is going to be M0, L0, and T0. Now equating all these, I'll be getting the values as you can equate. I'll be getting like this. C2 is minus 1. B2 is also minus 1. And A2 is minus 2. Okay. Now, substituting these values in pi 2, your equation is going to take the form like this. So, d to the power minus 2 and omega minus 1, rho minus 1 and mu. So, pi 2 is mu divided by rho omega d square, right? The same procedure to be repeated for pi 3. All the three repeating variables. If you understand how to form the equation for 1 pi, then it's going to be the same for n number of pi's, right? Again, same, t to the power minus 1 b3 and rho is ml minus 3, right? C3, and of course you have the value for q here, it is L3 t minus 1. Okay, now you solve for A1, B1, I'm sorry, A3, B3 and C3, you will get A3 is minus 3, B3 is minus 1 and C3 will be 0. So your pi 3 will take the form d to the power minus 3 omega minus 1 rho will be 0 and this is q. So your pi 3 will be q divided by omega dq. Right? Now the last important step, we have come to the end. So the function of pi 1, pi 2, pi 3 I have already stated, right? This is going to be equal to 0 I told. So this function, pi 1 we got it as eta and pi 2 it is mu divided by rho omega d square and pi 3 is q divided by omega dq. This is equal to 0. Now we can rewrite this as the pi 1 is a function of pi 2 and pi 3. So I'll take this function, I'll write the pi 2 value here. That's all. This is how you're going to derive the relation between eta and other parameters, right? So the other parameters are dimensionless eta in terms of other dimensional parameters, right? So this is how Buckingham's pi theorem finds its application in deriving the relation between different variables. Okay. So you have any doubts, you can text me and it will be clarified. Thank you for your patience and listening. We'll meet soon in the next lecture.